Let's take a look at another unit of measurement that involves moles that we often use in chemistry, and that's molarity. We abbreviate molarity as capital M, and it stands for our concentration. Our concentration is the amount of something in the solution, and the unit that we use is moles per liter. So our molarity, we abbreviate this as capital M, and it is equal to moles per liter of solution. If you've done the dilution training in lab, you'll know that we calculate molarities as well. So if you want to review this, actually going to that lab and looking at the lecture on how to calculate this molarity may actually help solidify this concept a little bit. All right, so what is a solution? We talked about concentrations in a solution. We haven't really talked about what a solution is. A solution is a homogeneous mixture of two or more substances, and usually it's comprised of a solute and a solvent. So the solute is what you put in to the solution, and you dissolve it in the solvent. So usually this is like a salt, or in this case, sugar. So it's any component in a solution other than the solvent. It's usually a solid. The solvent is the component of the solution that's present in the greatest amount. So most of it. And then this is the other portion. So a solution can contain one solute, or it can contain more than one solute. Most of the stuff we're going to be doing in here will only have one, so you won't really have to worry about complex solutions. We're going to be asking for just one thing dissolved in another. So an example of a sugar solution would be if you have sugar, which is your solute, dissolved in water, which is your solvents. Most of the stuff we're going to be looking at is dissolved in water in this class. If you have a solution where water is the solvent, we call that aqueous. We're going to talk more about that in later chapters. Let's talk about concentration. So our concentration is measured in moles per liter. We abbreviate that as capital M. I keep saying this over and over because this is a common mistake students make. They think capital M means moles or something. It does not mean moles. It means moles per liter. So please write this down and make sure you memorize that. When you see a capital M, it means moles per liter in chemistry. So our concentration is the amount of chemical in a given volume. Let's take a look at this example here. So these little dots here represent moles. So if we wanted to find the concentration of this solution here, we're going to say this is 25 milliliters. We can see that we've got 1, 2, 3, 4, 5, 6, 7, 8 moles in here, and it's in 25 milliliters. So 25 milliliters, if we convert it to liters, is going to be 0.025 liters. So over 0.025 liters. See what that concentration is. This would give us a really big number. 320 molar, which is not a reasonable, it's not a reasonable concentration at all. Most of your concentrations are going to be somewhere between like 0.001 and like 4 at most. The highest concentration you'll probably see in this class is 4. But it demonstrates the concept of you can see the moles in the volume. Let's take another look here at these same moles. We've added, let's say we add water up here. And so we've got 1, 2, 3, 4, 5, 6, 7, 8 moles. It was originally in water. We've added more water. So we've got 8 moles. And now we're in a different volume. We're in 50 mils. So this would be 0.050 liters. So that concentration here, as we have our volume has doubled, we're going to have a reduced concentration here. So we'd end up with 160. Now again, this is a completely unreasonable concentration. But you can see here that these numbers are dependent on both the volume and the amount of moles inside of the solvent in the solution. Let's do another example where we look at what's happening in the lab. So let's say here, this is our sodium chloride again. So when you go into the lab and you're measuring stuff out, oftentimes you measure solids on the balance, right? And a lot of times you'll be asked to find how many moles are in here. So let's go ahead and do that. See if you can do this on your own. So in order to find out how many moles of NaCl are on this balance right here, we need to use our molar mass from the periodic table again. So if we have 16.43 grams, and we want to know how many moles there are, we need our molar mass. So that tells us that we have 0.2811 moles on here. So this is 0.2811 moles of NaCl. If we had a different substance, if it was sodium fluoride or sodium bromide or something like that, it would be a different amount of moles. But this is what it is for sodium chloride. Now, once we get our amount of solute measured out on the balance, then we want to make a solution. So in order to make solutions in the lab, this is the steps that we take. You'll be doing this in one of your lab trainings. So you'll take your solid that you measure out, and you're going to put that into a flask. So let's say here we're going to make 500 milliliters of this solution. We put the solid in, and then you put in your solvents. In this case, this person's using ethanol instead of water. And so they add it, they stir it up, so they stir. And then once they do that, they finish filling it up to the line, the 500 mils. So we've got our solid in the solvent, and it's been dissolved. And that's how we make what's called a molar solution. So now, if I had said, you measured this much out on your balance, what's the concentration of the solution? Say we wanted to know how much this is. What's the concentration of this solution? Let's look at how to do that. So remember that concentration, the units are moles per liter. So we're going to need something in moles, and we're going to need something in liters. We can get moles from here. We can convert grams to moles, and we can get liters from here. So try this problem on your own and see if you can find the concentration of this solution. The molar mass on this cobalt chloride dihydrate, I'm going to look this up for you. Oh, wait, here it is. Okay, perfect. Okay, so you'll want to find concentration. Let me write this again. Okay, and we can use this to get to moles, and we can use this 500 mils to get to liters. Okay, so see if you can calculate the molarity of the solution. I've given you the mass on this since it's a big bulky compound. Let's take a look at how to solve this problem. In order to find our final solution here, remember that our unit is in moles per liter. That's where we're going. So we need to have something in moles, and we need to have something in liters. So let's get to moles first. So this balance read 10 grams. So 10 grams. I'm going to use this mass here to get to moles. So 170.48 grams per mole. Okay. This is good because our moles is on the top. See how it's on the top here? Moles is on the top over here. That's where we want it. So if we solve for this, we find that we have 0.0587 moles of this stuff, this cobalt-2 chloride dihydrate. Now we want to know over liters, right? So we need some kind of volume here. And it needs to be in liters. So we're going to get that here. So we have 500 milliliters, and we need to convert that to liters. So we know that in every 1 liter is 1,000 milliliters. So we're going to do that. 0.5 liters is what we end up with. So we can simply plug that volume in here and find out our concentration. So 0.0587 divided by 0.5 is going to give us 0.117 as our concentration. So this solution right here, that is the concentration on it. Now there will be some times in lab where you have to make solutions of a different concentration when you start with a liquid. So say we had this last one that we looked at, this 0.117 molar solution. And let's say someone asks you to make a 0.0117 molar solution, and you have to start from here. You're going to have to mix this with some more solvent in order to get here. Like, we've got to change the concentration somehow. And whenever you're changing concentrations, this is what we call dilution. This is a definition you need to know. So dilution is when you're going from a higher concentration to a lower concentration. When we're doing dilutions in chemistry, we can use an equation to solve for these. So I'm going to use this one, C1V1 equals C2V2. If you had chemistry before, you might have seen it in this format, M1V1 equals M2V2. They're the exact same thing. So please don't get confused. This means concentration. The C stands for concentration. The V stands for volume. And this is our solution 1. And this is solution 2, which is why we have the 1 and the 2. Okay, and this is the same thing. M stands for molarity in this one. So the units on these for our concentration is moles per liter, and our volume is liters. When we multiply these together, the liters cancel out because liters is on the bottom for our concentration. It's on the top when we multiply it. So each side of our equation is moles. So we're essentially saying moles of one thing equals moles of the other thing. And we can draw this relationship because when we take a little portion out of one flask and put it into the other, let's think about it this way. So here's our flask. If I use a pipette here, and let's say I draw out a little solution and I pipette it into here. I'm bad at drawing. And I pipette that into here. Whatever I draw up in here, let's say it's got like 3 moles in this pipette, and then I pipette it out. Well, that 3 moles gets put in this solution, and then you just add more solvent to it. So at the end of the day, the moles that you pull out of the first solution and the moles that you put into the second solution are going to be the same, which is why we can draw this comparison and set these two things equal to each other. So let's look at an example here. Let's say you have a 2 molar solution. Say this one is 2 molar, and you need 100 milliliters of a 1 molar solution. Let's say this is 100 milliliters. And you want this to be 1 molar. So we need to make this. In order to make this, we're going to have to pull out some amount and put it into here. So the question is, how much? How much do we pull out in order to put this in here? How much solvent do we put in here? Let's say we're using water solvent. How much do we need of that? We can use C1V1 equals C2V2 to calculate this. So for our stock solution, our more concentrated, this is going to be our first solution, and this is going to be our second solution, solution 2. So we can plug these numbers into our equation. So say that our C1 here, concentration 1, is our 2 molar. So we have 2 molar times some volume. We don't know because we're trying to figure that out, how much of it we need. Our concentration 2 is going to be right here. This is what we're making, 1 molar. And we're making 100 milliliters of it. Now remember that the units on this equation here are liters, so we need to convert that first. We can do that by dividing by 1,000. So we have 0.1 liters. So if you solve this equation, it's going to tell you the volume of solution 1. This here is our solution 1. So it's going to tell you this. How much of solution 1 do you need? So if you plug this into your calculator, you find that when you divide both sides by 2, you end up with 0.05 is equal to 1 molar times 0.1 liters divided by 2. So this is how many liters we need to pull out of our first flask. Most of the time in the lab, we don't measure things in liters, we measure things in milliliters, as you know from using a graduated cylinder. That's the unit on here. So if I wanted to make this solution, what I would do, I would pull out this many liters of this solution here. So if I wanted to convert that into milliliters, 0.05 liters, so milliliters, multiply that by 1,000, that's 50 milliliters. So I'd fill this up here, 50 milliliters of the 2 molar. Now I need 100 milliliters of my solution, of my 1 molar solution. So what I'm going to do is I'm going to fill the rest with water, or your solvent in this case. So the rest would be water. And that effectively gives us a 1 molar solution. One way to practicalize this, I guess if you want to say it that way, is you start with a 2 molar solution, right? And you go to 1 molar. You're cutting the concentration in half. So it makes sense that we start with 50 mils and we add 50 mils because we're cutting everything in half. That's one way you can kind of visualize it. Okay, so give this a shot yourself using the C1V1 equals C2V2. All right, see if you can figure this one out. Let's take a look at how to solve this problem. How would you make 10 mils? So 10 mils, we're going to make this, so this is our V2, of a 0.2 molar solution. This is our C2 from a stock solution of 0.5 molar C1. That's where it's coming from. So now that we've identified these variables, we can identify what's missing. So we've got C1, V2, and C2. We need to find V1, so we're going to do that. I'm going to write it as moles per liter so everything's really clear. Remember this capital M is moles per liter. V1 is what we're looking for. We don't have that. We need to find how much liquid we're pulling out of our first solution. C2 is 0.2 moles per liter. V2 is 10 milliliters. I'm going to go ahead and convert this to liters. So 10 mils it's going to equal 0.010 liters. Okay, so I'm going to multiply that. And I'm going to solve for V1. We divide both sides by 0.5. End up with V1 is equal to 0.004 liters. Okay, so again, this is a really small amount of liters that's hard to measure, so we're going to convert this into milliliters. We're going to go ahead and do that. We know that there's 1,000 milliliters for every liter. It's going to give us 4 milliliters. So I would want 4 milliliters of C1, i.e. the 0.5 molar. And if I want to make 10 milliliters of it total, that means I need to fill with solvent. to 10 milliliters, which would mean I need to add 6 milliliters of solvent to get to that total. So if I were to essentially put a recipe together in order to make our C2 solution, it would be to take 4 milliliters of the C1, or the 0.5 molar, and add 6 milliliters of water or solvent to it. And that would give me 10 milliliters of the 0.2 molar solution.